Hey everybody, hi John Knox. It's Sue King Irwin, aka Sue, our pal, the science gal, and I'm going to talk to you today about some fun science experiments. And so anyway, I'm going to start with a question. Put this away. I have 2 cups here. This one you can see is filled with water, right? This one, you might say it's an empty cup, but it's actually not an empty cup at all. It's filled with air. So we don't think of it as being anything, but it's air and it's all around us and it's really important. So what is air? Well, air is a mixture of gas molecules. Well, the reason that you can't see them is that they're very tiny and they're far apart from each other, but you don't know this. They're moving very fast, and of course you can't see them. What kind of air molecules are they? Well, most of it is nitrogen. 78% is nitrogen, 21% is oxygen, and that's what you need to breathe, to live. And there's only 1% that's everything else. So that's carbon dioxide, water vapor, any kind of pollution, anything that you smell. It actually is mostly argon, which you've probably never heard of, but that's what makes air. Now, let's see if you learned from this. I have 2 soda cans here, right? Now, they're emptied out, and if I ask you what's in them, would you say nothing? Or would you say, no, these are cans that are filled with air? Well, okay, I'm going to do an experiment with them. So what I'm going to do is I'm going to put a little bit of water in both of them, a couple ounces of water. And I'm going to set them on the stove. And I'm going to turn on the stove on high and wait for that water to heat up. And then we'll do an experiment at the end of this. In the meantime, I'm going to talk about air pressure, and I'm going to show you some fun things that you can do with straws that have to do with air pressure. So the next frame here, what is air pressure? Well, those molecules that are in the air, they're moving around really fast. Air pressure is the force of the collisions of those air molecules. Oh, here's my pencil. Okay, when those air molecules collide with something, that's what air pressure is about. And it's actually really strong. So if you think of a square inch, 15 pounds on 1 square inch. That's how much air pressure is. And we don't think of air as having any kind of pressure on us, but it adds up. When you think 15 pounds, that's like a really heavy baby or 3 big sacks of flour or something like that. On 1 little square inch, let me show you this calculation I did on this shoebox. Okay, it's about a foot. If I took a ruler, it's about a foot, 12 inches by 6 inches by 4 inches. And if I calculate the surface area on this shoebox, here's a calculation. Anyway, it adds up to 288 square inches times 15 pounds per square inch, 4,300 4,300 pounds on this shoebox. That's over 2 tons. So 2 tons of pressure, but how can I lift it so easily? Why do I not even feel the pressure on this box? It's because there's 4,300 pounds of air pressure on the inside of the box as well as the outside. So nothing happens to it. Imagine our bodies. We have way more than 2 tons of air pressure hitting our bodies, but it's the same inside as outside. So we don't feel it, we don't crush or anything like that. Okay, so that's about air pressure. Now I'm going to show you some fun things that you can do with a straw. Okay, and it has to do with air pressure. So the first thing, now you guys have probably done this, maybe if you're bored at a restaurant and you're waiting. So you take a sip of water, put your finger over the top of it, and did you ever try this? And there's water inside. Did you ever wonder why does the water not fall out of the straw? Well, you know that gravity is going to pull the water down, but right now with my finger over the top of it, there's air pressure pressing up on it, but there's no air pressure pressing down on it. And so the air pressure here keeps it in there. But if I let go of my finger, the water falls out. Did you get that okay? All right, so I'll try it again. I'll show you again. Okay, so there's water that's caught and trapped inside, and I'm gonna let go. There it goes. Now, if I take a safety pin and poke some holes in this straw, I'm gonna poke holes like that. Now I'm gonna try the same trick. See if I can suck up the water. Can't suck up the water. Why is that? Well, let's look at a picture of the straw. Okay, so here's a straw. Here's my finger over the top. There's no air pressure. The air pressure is there. But then when I make holes in here, so now the air can go in there into the holes. And so when I'm sucking it, the air is just coming straight in here. And so there's no air, there's no pressure that can go up like this. Because see, before I was sucking out the air that was in the straw and pulling up the water. Now I can't do that because the air just comes straight in. So it's kind of interesting. You could try this at home. And the last thing I'm going to do is I'm going to show you something else you can do with straws. I'm going to cut this straw. So I cut out the holes so I don't have to bother with them. Now I'm going to cut the straw in half. Okay, now I have two little straws. Now, get down on my knees to do this trick. I hope it works. Okay, I'm going to put one straw in the water, and the other one, I'm going to put it right angles. I'm going to blow. Did you see some water come out? Can you see a little bit of water? All right, let's try it one more time. Okay. There, it's a good one. There. Okay, so what happened? How did that water come up and out onto the table? Well, what happened was I was blowing the water. Now, remember when I was sucking up the water in the straw, the reason that the water comes up actually is a little bit more understanding. Let me show you the picture. Okay, so the water in the cup, see there's air pressure on the surface of the water. And the air pressure, so when I'm sucking up on the straw, back in the last picture, when I'm sucking up right here, then the air pressure makes the water go up because I'm lowering the pressure here. So what happens when I'm blowing across the straw, it's similar. So I'm lowering the pressure that's in the straw here so that the air pressure here pushes the water up. And then when I'm blowing, the water that's at the top gets blown across. And this is actually, it's a principle called Bernoulli's principle. And this is how airplanes can fly. I don't know if you've ever wondered how can airplanes stay in the sky and not fall down. It's because they're moving really fast. So when the air molecules are moving fast across the top, right here, then they're moved out of the way, so there's lower pressure here. So the pressure here makes the water go up, and you blow it, and then the water goes out. Now I could show you another way of doing this that Hank, my cameraman, has suggested. I'm going to try it. You could try this at home. Isn't this a cool straw? It's gold covered. Mrs. Rudy gave it to me. If you cut it and don't cut it all the way through, so it's hanging on by a little bit, it might be easier to do this trick because then it's attached. So the trick is you have to get the right angle. So let's see if this works. It doesn't work any better. So I suggest Then you cut it all the way off and then try it like this. So that's my straw trick. Now we're going to go back over to the stove and see how those soda cans are doing. So okay. For this one, I'm going to put on my goggles. Oh my. Yeah, I'd say this is working pretty well. Okay, so is the camera on? All right. I'm going to turn it off because it's really hot. Okay, I'm going to take some, I have a bowl here of water. I'm going to put some ice cubes in it. Now, what's happened here, okay, so I'm going to just do the first experiment and then explain it. So I'm going to take the can, flip it upside down. Did you see how that happened so quick and loud? So, wow, that can is pretty well crushed. Okay, now I'm going to turn this on a little bit. Okay, so what happened here? That was pretty dramatic, huh? So what happened is that you can see that the water that was inside the can, now see this one here, okay, so we need to put a little bit more water in here. I'm going to get my water, put it in. And we're going to heat it up again. Okay. So what happened, thank you. So what happened was that you saw that the can was filled with air in the beginning, but as the water heated up, it turned into steam. And steam, what that is water in a gas form. So there's water gas molecules were moving around inside here, and they were coming out through the top. They pushed all the air out, and it was filled up with water vapor or water gas inside it. So we're going to do that again and see the steam coming out. Once the steam comes out, it's pushed the water out, it's pushed the air out, so the can is filled with water vapor. Then what happens when I turn it upside down into the bowl of cold water is that very quickly the water vapor that used to be liquid turns back, it condenses back into liquid. And then so it lowers the pressure inside the can. So then the amount of air pressure on the outside of the can crushes it very easily. How much air pressure is that? Well, let's get my calculations. I'll be right back. All right, while we're waiting for that, here's my calculations. The surface area of a soda can, here's one that's not crushed. Okay, it's about 5 inches high, diameter 2.5 inches. When you add up the surface area of it, here's my calculation. It turns out to be 750 pounds. Now you know that people weigh way less than that, and you can easily crush a soda can, right? 750 pounds of pressure on this can doesn't crush it at all. However, and the reason is the same as the shoebox. There's the same pressure inside as outside. But you can see the steam starting to come out here, and you can see that as the steam is rising, it's pushing the air that used to be inside the can out of the can. So now the steam is filling up the can. When the steam condenses back into liquid water quickly, we'll do it again. It crushes it immediately because inside is a vacuum. In other words, there's very little air molecules inside or water molecules inside. Lots of air pressure on the outside crushes it just so quickly like that. So that is the end of all my experiments. Did you see me put on my goggles? Okay, this is the end of all of my experiments, and I'm signing off. So have a good day, John Knox. Bye.
I think you should watch it.